Imagine the digital world as millions of separate glowing islands. Each home, office, and data center is its own private territory, separated from the rest by a silent, dark void. To share information, these islands have to talk to one another. But there's a problem. A cellular network, a fiber optic cable, and your home Wi-Fi all use different digital languages to organize their data. When a message from one type of network hits the border of another, it is instantly rejected. The receiving network doesn't recognize the format, so the communication fails. This is why we place a network gateway at the boundary. It sits between the two networks, catching incoming data and translating it into the exact format the receiving side expects, allowing it to pass through safely. Think of it as a border checkpoint between two countries. It verifies your credentials for security and translates your paperwork, so you can move freely through a new territory. It's common to confuse gateways with routers, especially since they often live inside the same box in our homes, but they actually handle two different levels of travel. In this diagram, notice how the routers around Network B guide data between similar neighboring areas. A router is like a domestic traffic director. It manages movement between devices that are already part of the same network type. But when data needs to leave that local area and enter a completely different environment, like moving from these office computers into the wide area network in the center, it has to pass through these gateway nodes. This is where the gateway performs its most important task, protocol translation. It takes the data packet apart, translates the instructions, and rebuilds it so the other side can understand it. While it's translating, the gateway also checks your security clearance to keep out unauthorized traffic. Once the data is cleared and converted, the gateway finds the most efficient route for it to take through the new network. Most home Wi-Fi boxes are actually combination devices. They act as a router to connect your phone to your smart TV and as a gateway to translate all that data so it can talk to the rest of the internet. This translation work is what keeps a modern smart factory running smoothly. Factories are full of tiny sensors that use faint, specialized radio signals to save battery power. However, the massive servers in the cloud require a much heavier, more complex digital language to process that information. An IoT gateway listens to those faint sensor chirps, bundles them together, and converts them into a solid block of data that the cloud servers can actually use. We see this same bridge being built in office phone systems. A VoIP gateway allows old analog landline phones to talk to modern internet calling services. It listens to the electrical signals from the old hardware and translates them into digital packets for the web. By acting as a universal interpreter, gateways allow businesses to adopt new cloud or smart technologies without having to throw away their existing equipment. Those isolated islands of technology we saw earlier only snap together because of the work gateways do at the borders. The global internet is a massive patchwork of diverse systems, all woven together by thousands of these gateway nodes sitting at every intersection. If these interpreters stopped working, the web would fracture. Our devices would lose their ability to talk to the outside world, and traffic would pile up at the borders with no way to cross. The gateway is the critical interpreter, the security guard, and the bridge that keeps our digital world connected. While they often go unnoticed, network gateways are the only reason our world's many incompatible systems can finally speak the same language.